So I have the problem integral of x cube minus 2x plus 3 by x squared plus x minus 2 dx. So let's see how we can use partial fractions in order to integrate this using the partial fraction method. So as we see that the degree of the numerator is greater than the degree of the denominator, we can divide the two polynomials, polynomial in the numerator and polynomial in the denominator. And therefore, if I have this divided by this, let's see what is the division process going to yield through division algorithm. So x gives me, multiplied with x square, x cube plus x times of x square minus 2x. So this gives me minus x square, and plus 2x and minus 2x get cancelled and I get plus 3. But again, this can be reduced with minus 1, which gives me x times x square times minus 1 minus x square minus 2 minus 1, which is plus 2 minus x plus minus plus, is how we get 1 plus x. And let's see how this reduces to. Therefore, I can reduce x cube minus 2x plus 3 divided by x squared plus x minus 2 as so this is how we can just reduce this using this and this. The quotient, the remainder, the quotient, the remainder, and the denominator. So once I obtain this, now integration of this is nothing but integration of the right hand side. And this is going to be integrated using some standard formulae and of course partial fractions. So let's see how we can integrate this, which is indirectly equal to this. Therefore, integrating on both sides, I get this to be x cubed minus 2x plus 3 by x squared plus x minus 2 of dx, which is integral of x minus 1 plus integral of this dx. Now let's split the integral using the expansion through brackets. That is, this step is followed with integral x dx minus integral dx, because this can be split as x dx minus dx under integral. Dx, and this is nothing but x square by 2 minus dx, because integral x dx using the formula x power n plus 1 by n plus 1 6, and we know that integral dx is x plus integral of this. Now how do we evaluate integral of this is the biggest question out here, which is connected with the topic itself, which is partial fraction method. Now it is very essential that I split this using the partial fractions. So let's see how I can split this term 1 plus x by x squared plus x minus 2 using the partial fractions. We know that this can be split as 1 plus x, and then I can find the factors of this as x minus 1 into x plus 2, because x plus 1 into x plus 2 are the factors for x squared plus x minus 2. Now this can be split as a by x minus 1 plus b by x plus 2 using the partial fractions. That implies a times of x plus 2 plus b times of x minus 1 is what I get with the denominator getting cancelled, is how we do in the partial fraction method. Now taking common, this is 2a minus b plus a plus b x, which is this. Now comparing the like coefficients, 2a minus b is 1 and a plus b is also 1, equating the like coefficients, and then using the elimination method we get this to be 3a equals 2. That implies a is 2/3 and b will be 1 minus 2/3, which is 1/3 when I substitute a in one of the equation. So therefore I got a is this and b is this, and hence my partial fraction. Therefore substituting the values of a, which is 2 by 3, and b, which is 1 by 3 in the partial fraction, I get this to be 1 plus x by x squared plus x minus 2 is a times of x minus 1 plus b times of x plus 2 is what we get this for this. And substituting this in the integral, I get this to be x squared by 2 minus x plus integral of this being substituted with 2 by 3 of x minus 1 of dx. Now when I split this brackets, expanding the brackets and using the integral separately, I get this to be 2 by 3 integral of 1 by x minus 1 dx, and this will be 1/3 of integral 1 by x plus 2 dx, which is simplified using x squared by 2 minus x plus 2/3 of, we know that integral of 1 by x minus a is log mod x minus a, and of course plus c. So integral 1 by x minus 1 is log mod x minus 1, and this is 1/3 log mod x plus 2 plus c, is how we obtain the integral. Therefore the overall integral of x cubed minus 2x plus 3 by x squared plus x minus 2 dx is x squared by 2 minus x plus 2 by 3 log mod x minus 1 plus 1/3 log mod x plus 2 plus c, and this integral is obtained strictly by using the partial fraction, this split into two partial fractions. So partial fraction helps in integration of few of the functions. Now let's see the reduction formulae in the topic of integration. So what is a reduction formulae? As we see, the word reduction is about reducing continuously, or reducing is the concept which we use in reduction formulae. So to go with the heading, reduction formulae. So for example, I wanted to evaluate integral of x power n e power x ax dx. Let's see how we can evaluate this. As we clearly see that there are two functions, one is algebraic and the other is exponential, then clearly by using the Eilate process, this comes first and this comes second. So taking this as the first function, and this as the second function, integration by parts uses the formula integral of first and second is first integral of second minus integral derivative of first into integral of second whole of dx is how we obtain. So using integration by parts, over here I have the first function which is x power n and my second function which is e power ax, and hence the formula reduces to first function integral of second minus integral derivative of first into integral of second whole of dx. Now this, on further simplification, gives x power n integral of e power ax is e power ax by coefficient of x, which is a, minus integral derivative of x power n is n times x power n minus 1, and this is e power ax by a dx, because integral e power ax is e power ax by a and derivative of x power n is n times x power n minus 1, using the standard formulae for derivatives and integrals respectively. And this, with n and a are constants, they come out and I get ax dx. Now let's see what happens if I reintegrate this, because this integration of x power n e power ax dx is not completely simplified, but I got some reduction as x power n minus 1 e power ax dx. Let's see what happens if I reintegrate this again by using integration by parts. Therefore, integral of x power n minus 1 e power ax dx, this being first function algebraic and this being second function, I have first into integral of second minus integral derivative of first into integral of second dx. This would be nothing but x power n minus 1 e power ax by a minus n into x power n minus 1 by a dx. So here again we see that this is reduced to n minus 2, and here x power n is reduced to n minus 1 and n minus 1 is reduced to n minus 2. Therefore we get a reduction where n reduces to n minus 1, this reduces to n minus 2, and again I simplified this using by parts, this reduces to n minus 3 and so on. Therefore we get a continuous reduction from n to n minus 1, n minus 1 to n minus 2, n minus 2 to n minus 3, and so on and so forth. Therefore finally it has to reduce to 1. Therefore we take this reduction formula of x power n e power x dx as x power n e power ax by a minus n by a, and this is taken as in minus 1. If I take this as in equals this, is how we see the formula. The formula says that in is equals this, which is this of in minus 1, where in minus 1 is integral x power n minus 1 e power ax dx, is how we call this as reduction formula for integral x power n e power ax dx. Now what is the significance of reduction formula is the biggest question out here. Let's see what exactly is the use of reduction formulae in evaluating few of the integrals. Now let's see the significance of reduction formula which we have taken, that is integral x power n e power ax dx. The significance so generally reduction formula helps in evaluating few of the integrals. Say for example, I wanted to evaluate integral of x cube e power 5x dx, then clearly I see that this, when compared with x power n e power ax dx, my n is 3 and my a is 5, is how I get it. Now I have the reduction formula for x power n e power ax dx is x power n that is, this is in minus 1 is what we get. Therefore, using this reduction formula of integral x power n e power x dx, which is equal to x power n e power x by a minus n by a integral of this, which is in minus 1. Let's see how I can evaluate this using this reduction formula. So in order to evaluate integral of x cube e power 5x dx, I have my n which is equal to 3 and a which is equal to 5. So n is 3 and a is 5. N minus 1, which is I2. This is In, therefore my I3 is equal to this, because the formula of In with n equal to 3 implies I3 is this times x cubes e power 5x of I2. And suppose I would like to find n is equal to implies my I2 will be integral of x square e power 5x dx, which I am going to find using n equal to 2, and here of course a is equal to 5. So n equal to is I2 equals x square e power 5x by 5 minus 5 by 2 integral, or this is I of n minus 1. So continuously I get this to be I1, which I am going to find using n equal to 1. So n equal to 1 and a equal to 5 gives me I1. Implies I1 using reduction formula is x power 1 e power 5x by 5 minus 1 by 5 integral, or this is I naught, because n is 1, so I naught is what we get. Now I naught is nothing but integral of x power 0 e power 5x dx, which can be evaluated using x e power 5x by 5 minus 1 by 5 e power 5x by 5, because integral of e power 5x is e power 5x by 5. Is what we get in terms of each. Now it is our duty to substitute each of I1 in this and I2 and I3 so that I get the entire problem using I1, I2 and I3. So let's substitute and see how we get each of them respectively. Therefore, substituting each of I0, I1, I2 in I3, we get I3 equals integral of x cubed e power 5x dx, with each of substitution stepwise gives us the overall answer as x cubed e power 5x by 5 minus 3 by 5 square x square e power 5x plus 6 by 5 cube x e power 5x minus 6 by 5 power 4 of e power 5x plus c is how the reduction formula reduces using I0, I1 and I2. So the significance of reduction formula is that for larger n, integrations can be simplified by reducing the value of n and then finding. So reduction helps for larger values of n in integration of the functions. Integration of I3, which is x cubed e power 5x dx, is done with this. Now let's see the reduction formula for sine power nx. That is, if I take integral of sine power nx as in, then this reduces to some continuous reduction which can be helpful in finding integral of sine power nx for larger values of n. So integral of sine power nx dx is assumed as in, and then sine power nx, which can be written as into sine x using the laws of indices. A power m times a power n is a power m plus n, which reduces to n. Now this is assumed as the first function and this as the second function, and then integration by parts leads to first function into integral of second minus integral derivative of first into integral of second of this. Thus, on further simplification, reduces to sine power nx, and integral sine x we know by standard formula is minus cos x minus derivative of this, which is n into n minus 1, n into x power n minus 1 into derivative of sine x, which is cos x, using the chain rule, and then integral of sine x, which is minus cos x dx, is how this is further simplified, and then rearranging minus sine power n minus 1x cos x and minus into minus, which is plus n minus 1 integral dx is what we get when simplified. Now we know that sine square x plus cos square x is 1, and therefore cos square can be written as 1 minus sine square. So this is replaced with 1 minus sine square. So cos square replaced with 1 minus sine square, because sine square theta plus cos square theta is 1, and then expanding by brackets we get this to be minus sine power n minus 1x cos x dx plus n minus 1 integral of sine power n minus 2x dx, and then replacing this minus of n minus 1 psi power n minus 2x sine square x dx is what we get when this is expanded using the brackets. Now, as I see this, I get this to be n minus 1x cos x and this is n minus 1 times in is integral sine power nx dx. So integral of sine power n minus 2x dx will be in minus 2, and this would be n minus 1 times sine power n minus 2 into sine square is sine power n using the laws of indices. A power m times a power n is a power m plus n. So n plus 1 cancels 2 and n is remaining. So this reduces, therefore in equals integral sine power nx dx is given by the formula minus sine power n minus 1x cos x plus n minus 1 in minus 2 minus n minus 1 in is what we get when I substitute this with the value as we have. Now, taking in to the left, we get the reduction formula for in, that is integral sine power nx dx. Let's see how we can do continued from the session.